Hello guys, I hope you are all keeping safe in these unprecedented times. Let's all hope and pray that the entire world comes out of this as early as possible. So let's start our coursework after midterm. Till midterm, we had completed the first layer of the TCP/IP stack, the application layer. So we'll start with transport layer. This would be an introduction to the transport layer in this first lecture. Then we'll go into the specific details of this particular layer. So in this lecture, we'll have a very basic introduction of transport layer. We'll see the relationship of transport layer with the network layer. We'll then specifically see the role of transport layer in internet, and we'll discuss one of the functions of transport layer, multiplexing and demultiplexing. Let's start with a generic introduction of this layer. Uh, a transport layer protocol provides for logical communication between application processes running on different hosts. Read this again. A transport layer protocol. If you remember the discussions in the application layer, we had seen many different applications, and one of the requirements of every networking application is that that particular application has to specify which transport layer protocol it is going to use. If you remember, every application we discussed either has to use TCP or UDP. The TCP and UDP are transport layer protocols. We'll discuss them in details in this layer. So a transport layer protocol, so apparently there are two protocols, TCP and UDP. These protocols provides for logical communication between application processes running on different hosts. Let's break down this sentence one by one. First part, it should be clear a transport layer protocol. It is either TCP or UDP. So these two protocols provides for logical communications. I have made these two words bold, logical communication. We'll discuss them with an example. So these two protocols provides logical communication between application processes running on different hosts. Let's understand first what logical communication means. By logical communication, we mean that from an application's perspective, it can be an application. It is as if the hosts running the processes were directly connected. In reality, the host may be on opposite side of the planet, connected via numerous routers and a wide range of link types. Application processes use the logical communication provided by the transport layer to send messages to each other, free from the worry of the details of the physical infrastructure used to carry these messages. Um, I guess we should take an example to understand this particular thing. Now let's try to understand what does it mean to have a logical communication between processes running at different hosts. Now let's assume we have a client machine and we have a web server. And this client machine and this web server is connected through a number of links. If you remember the traceroute tool you have used previously, we have a number of links between this client machine and this web server. Let's assume it's any web server. Say for example this is your Google web server. So this client machine fires up a browser. Let's say it opens up a browser, basically a browser process, and this browser process is requesting some page from this web server, another process in the web server. So this is an application process, the client browser process, and this is a process in the web server. So there is a communication between this process and this process. So apparently the data from this process would be first delivered to the socket, and from the socket to the transport layer, then from the transport layer to the lower layers, and then the data will flow through these individual paths, these intermediate links, and finally to the socket at the other side, the web server side, and finally the data will be delivered to the other process, and then any response coming back will follow the same way. Now when we talk about logical communication, it means that this process this process is unaware of all these intermediate links. They simply understands that they are directly connected through their sockets. So say this is the socket of the client side, this is the socket of the server side. So this client process delivers the data to this socket, and from this socket to the transport layer, the other side same is same. So for this process, it simply knows that the transport layer would deliver the data to the other side. So it is as if they are directly connected. They are unaware of this underlying process. For them, they are directly connected, but this is not the exact physical connection. This is some sort of a logical connections which is utilizing the physical connection. This is the actual physical connection. So but for these processes, this actual physical connection is meaningless. It simply understand it needs to deliver its data to this socket, and this socket is directly connected to the socket of the other side through its transport layer, and that is the exact meaning of a logical connection between the processes at both the ends. I hope the first part is clear, providing logical communication between application layer processes running on different hosts. Now let's discuss the relationship of transport layer with the network layer. You may wonder why we require to understand the relationship between transport layer and network layer. It's simply because transport layer takes the services of network layer. Remember when we were discussing application layer, we saw that the role of the application layer is simply to take the data from the different applications and then deliver the data to the transport layer through its socket. So apparently application layer understands that the data will be delivered by the transport layer to the other side. But again, transport layer takes the services of the network layer. So it is not the transport layer who is doing the actual delivery of the data, it is the layers below it. So we have to understand the relationship between transport layer and network layer. Now, when the application layer deliver the data to the transport layer, what it does is it divides the data into a small number of chunks which we call as packets, or in the internet terminology they are also known as segments. So transport layer divides those data into number of smaller packets, put some extra information into those packets which we call as header information. We'll again discuss those headers in detail later on in this transport layer, and then send those packets or segments to the layer below it, that's the network layer. So transport layer understands that those packets will be delivered by the network layer and the layers below it to the other end. So we have to specifically understand the relationship between transport layer and network layer. Now the relationship between these two layers is very important. Let's understand it. A transport layer protocol provides logical communication between processes running on different hosts. A network layer protocol provides logical communication between hosts. The difference is subtle but very important. Look at the difference between these two parts. Logical communication between processes running on different hosts, and logical communication between hosts. So it's between processes running on different hosts and logical communication between hosts. To understand this difference is a very important part to understand the relationship between these two layers. So we'll take a very beautiful example from your textbook to understand this relationship between these two layers. Let's have this example right now. So now let's take this example. Say we have these two houses in two different cities, and these are name of five children living in this house, and these are the names of five children living in the other house. Now let's assume that these two houses are connected by these roads. There is a river in between, another road, there's a bridge over this river, and another road, and finally it leads to the other house. Now assume that it was older days and these children like to write letters to these children at the other house per every month. So every month Emmy would write a letter to each one of these children. Bob would write a letter to each one of these children, and the same way from the other way Priya would write letters to every other children here, Queen would write a letter to every other children here, and so on. Now assume that uh, this in this house, let's take X, and this side let's take Y. Assume that X and Y are the elders in these respective houses. So X is the father of these five children and Y is the father of these five children. So every month these children would write letters, and after writing the letter they would simply hand over the letter to their father, X in this case. And the same way at the other end, these five children would write the letters and then hand over the letters to their father. And that's it for the children. They simply assume that their father would deliver the letters to the other house. They're not interested how their father is delivering the letters. They simply understand that their father will deliver the letter to the other end. What exactly happens is the postman comes to this house, another postman comes to this house, the postman takes the letter from the father. So the father is not going outside of the house, the father is delivering the letter to the postman. So this postman takes the letter from the house. Say we have a post office here. We have a post office here. So the postman takes the letters from X, goes to the post office. Now another postman would take the letters and travel over this path. Say we have another post office here. Another postman would cross the bridge. There is another post office here. Another postman would take the letters to another post office. From this post office, finally a person would go to the other house and deliver all the letters to Y. Now it's a responsibility of Y to deliver the individual letters to the children which he has received from the postman. Now understand this very clearly. Who is delivering these letters? It is the postman. The postman at this side and the postman at this side. But for the children, they are unaware about this process. They simply deliver the letters to their fathers, and they assume that their father is delivering the letters to the other side, but it's actually the postman who is delivering the letters. So the father is not going out of the house, it's a postman who is traveling along the path. Now let's compare the same situation to networking. It's the same thing. Let's assume this is one machine, this is another machine, and these are the different processes. All these are different processes. It may be a browser process, it may be a email process, so these are different processes. The data they are generating, the letters are same as data. The data that are being generated are delivered to X this side and Y this side. So X and Y is similar to the transport layer in networking. So the application processes deliver the data, the letters, to the transport layer, and transport layer is delivering the letters to the postman. Postman is like the network layer. Now remember, transport layer is not going outside of the house. It is the network layer, the postman, who is moving. The postman take the letters from this side and deliver to the other side. The same way the postman is taking letters from this side and another postman is delivering to the other side. So transport layer role is to take the data from the application layer and then give this data to the network layer. The network layer is delivering the data from this house to this house. So from this host, so this is one host and this is another host. Now who is delivering the data from one host to another host? The postman. The postman is not delivering the data to these processes. Who is delivering the data to these processes? The father here, the father here. That means the transport layer deliver the data to these individual processes. The transport layer takes the data from the individual processes. The transport layer also distributed the data to these individual processes. So process to process communication, process to process, a letter from Amy to Priya, a letter from Amy to Queen. So this is process to process communication. This is done by this transport layer. Transport layer is taking data from Amy, transport layer is delivering the data to Priya. The host to host communication, the letters from this house to this other house is done by the postman. This is same as delivery of data by the network layer. So understand this subtle difference very clearly. The process to process communication is achieved by this transport layer. The transport layer does not move out of the house. The host to host delivery is done by the network layer. In the same way, transport layer is not implemented in the intermediate routers in the links. You can see that the transport layer does not move out of the house. It is a network layer who is doing this task. So transport layer is implemented only in the end systems. They are not implemented in the intermediate host. So understand this subtle difference very clearly. Network layer provides host-to-host communication. In this example, house communication. Transport layer provides process-to-process communication. In this example, this father is helping to communicate between this child and another child at the other end. I hope the relationship between transport layer and network layer is clear from the given example. Now we'll discuss about transport layer in the internet. Transport layer specifically the TCP IP stack in the internet, because we are taking internet as our example network. By now it should be clear that the transport layer in internet consists of two protocols. One is TCP and the other one is UDP. TCP stands for Transmission Control Protocol, UDP stands for User Datagram Protocol. The basic difference between these two protocols are that these two protocols provides a different set of services. That means UDP provides a different set of services, TCP provides a different set of services. Your application would be using TCP if it requires the set of services provided by TCP. Your application would use UDP if it requires the set of services provided by UDP. We'll discuss the difference between these two protocols in detail, but in simplistic terms, the main difference between these two protocols is that UDP is a lightweight protocol. It provides a lesser number of services. TCP is a heavier protocol. It provides much more services than UDP. UDP is basically an unreliable service. TCP is a reliable service. UDP is an unreliable service means that the data that is being sent by the application layer, and if that application is using UDP, it simply takes the data from the application, divides it into a number of packets, and then send it to the network layer without bothering whether the data will be delivered to the other end or not. The data may get lost, but it doesn't bother. TCP, on the other hand, specifically guarantees that the data will be delivered to the other end. Now, both TCP and UDP, which are the protocols of the transport layer, takes the services of the network layer. Network layer is also known as the IP layer. Now, because transport layer takes the services of the network layer, we need to understand the service model of the network layer or the IP layer. The service model of the network layer is that IP layer is known as the best effort delivery service. It means that the network layer tries its best. That's the meaning of best effort. It tries its best to deliver the data to the other end, but it does not give any guarantee that the data will be delivered. That means the data can get lost. It also does not give any guarantee about the timing. That means it does not say that the data will be delivered from one end to the other end within a specific period of time. It may take any amount of time depending on the intermediate delays. So basically the network layer is an unreliable service. It does not give any guarantee about the delivery of data. It does not give any guarantee about the timing of the delivery of the data. And transport layer take the services of this layer, which doesn't provide any guarantee. Now TCP, which is a protocol of the transport layer, provides guarantee. So it looks like a funny situation. TCP uses the services of IP. IP does not give any guarantee, but TCP, which takes the service of the IP, guarantees that the data will be delivered. Now, how is it possible? How is it possible to give guarantee if you take the service of someone who does not give any guarantee? So we'll see how TCP provides this guarantee when we'll discuss TCP in detail. UDP, on the other hand, does not provide any guarantee. It simply tries deliver the data to the network layer, and that's all. So as of now, understand that there are two two service models of the transport layer in the internet. One known as TCP, which provides guaranteed delivery of data. The other one is UDP, which does not provide any guarantee of data delivery. Now you might be wondering why someone would be interested to use a service which does not provide any guarantee. Why would anyone be interested to use UDP? The main reason is that because UDP does not provide any guarantee, the amount of work it needs to do is much less than the amount of work need to be done by TCP. Because TCP provides a guarantee, that's why it has to do some extra work. We'll see what those extra work are. And because TCP has to do those extra set of works to provide uh, reliability, that's why TCP is slightly slower than UDP. And that's why those applications for whom timing is important than data integrity is interested in using UDP. For example, if you are live streaming a say some sports match, some football match, then the main consideration is the data should be delivered to the other end as early as possible. If some data is lost in between, that can be concealed. So this sort of application would be interested to use UDP. On the other hand, application for whom reliability is important, for example, email or file transfer, where you cannot afford to lose data, those applications would definitely use TCP. So the transport layer in the internet is characterized by these two protocols, TCP and UDP. The UDP basically provides two very simple services. One is known as multiplexing and demultiplexing. The other service is error detection. TCP also provides these two services, but apart from these two services, TCP also provides many different services. We'll discuss all these tips in detail. Now we'll start discussing the set of services offered by these two protocols, UDP and TCP. The first function, multiplexing and demultiplexing, this is offered by both of these two protocols. So multiplexing and demultiplexing is one of the basic services that is provided by both TCP and UDP. Uh, let's understand what multiplexing and demultiplexing means. The exact way of doing multiplexing and demultiplexing will be discussed in the subsequent lecture. Now, the most fundamental responsibility of UDP and TCP is to extend IP's delivery service between two end systems to a delivery service between two processes running on the end systems. It simply means that the network layer is providing data delivery between host to host, but finally the data delivery to the different processes is to be done by the transport layer. Go back to the example of those letters between those children. So basically it's either TCP or TP has to take the data from the network layer and then deliver the data to the appropriate application layer process. Multiplexing is taking the data from the different application layer process, the different sockets, and then delivering those data to the network layer by dividing it into a smaller number of packets. And demultiplexing is the opposite one, taking the data from the network layer and then dividing it, distributing it to the different processes. So that's the basic idea of multiplexing and demultiplexing. The exact details, how this multiplexing and demultiplexing is done by TCP and UDP, will be discussed in the subsequent lecture. Till then, keep safe, keep basic hygiene, and again, let's hope that uh, the scientists who are working on this disease, COVID-19, are capable of finding a solution as early as possible. Till the next lecture, bye bye and take care. Thank you.